Okay, hello Cloud Gurus. Welcome to the lab for architecting to scale, and we're going to do some auto-scaling experiments. So you are consulting with a pharmaceutical company that's new to AWS, and every night they have these series of jobs and calculations that run against data that they uncovered in their day's research. Now, some days they have lots of data, and some days they only have a little bit of data, so they need some sort of extensible scalability. They do have some knowledge about scalability on AWS, but they're kind of skeptical that it's going to work for them. And since they're scientists, they want objective proof that scaling works. So your task is to design and conduct an experiment to show how scaling works in the most cost-effective way. So let's break this down. First, we're going to have to design an experiment to demonstrate auto-scaling to the scientists using cost-effective methods. Second, we're going to have to build the scenario that simulates heavy computational load so that we can trigger that scale-out process. And then we also have to demonstrate scale-in as that load diminishes. So if you're choosing the expert level path, this is where you pause the video, you go and just build this thing. Then come back, resume the video, and you'll see what I did in this case. Again, there's no right or wrong answers. There's many different ways to do this, but you'll just see one option. If you're at intermediate level, the next slide is going to give you some hints that may help you get started. So regarding sequence number 1, task number 1, the hint here I'm going to give you is X marks the spot. For number 2, sometimes stress is good. And for number 3, there's a very interesting dynamic here. Those are all the hints I'm going to give you. You can pause the video and go build something. If you keep watching, I'm going to go into the walkthrough where you're going to see how I built this. So if you took the intermediate path, then you'll remember that I gave you a hint on how to build this environment. And I said that sometimes stress is good. Well, in this case, it's very good because it allows us to simulate, or it actually produces, high CPU load that we can use to trigger scaling events. I'll show you how it works with a little demonstration. On the left-hand side, I'm going to use top, which just monitors processes. And then I can issue the command stress, decide how many CPU processes I want, and what's the timeout. In this case, I'm telling it to run for 15 seconds. Now you can see on top, we've just consumed 100% of the CPU. So we can use this little utility to generate artificial load on instances and force them to scale. So we can get started on our experiment by going out to EC2 from the console. Then under launch configurations, we're going to create a launch configuration. I'm just going to pick a normal Amazon Linux AMI. And just for kicks, I'm going to use M5 large. And because one of our objectives is to have the most cost-effective, I'm going to use spot instances, and I'm going to put a number that's well in excess of the going rate. I also want to enable detailed monitoring, and I'll explain a little bit more about why I want this later. These instances don't need public IP addresses. And also I'm going to insert a startup script, and you do that in user data. It can just be a bash script in this case. What the script is doing is it's doing an update. We're installing the stress utility and then launching stress with a timeout of 10 minutes. So in essence, this is going to start up and then just burn for 10 minutes at 100% CPU. So now that we've created the launch configuration, we can go create the auto-scaling group. And I can select this from the launch configuration I just created. I'm going to configure all subnets just to make sure that I have plenty of capacity for my spot instances. I'm going to change the health check grace period down to 60 seconds, and I'm also going to check the CloudWatch detailed monitoring. Now I want this to scale between 1 and 3 instances, and I'm going to use a dynamic scaling policy here. I want the target CPU rate to be 60%, and I'm going to say that the instances need 60 seconds to warm up. Now I'm finished, and as soon as I hit that Create Auto Scaling group, AWS is going to go out and start provisioning my instances. Now, one thing to note here is the default cooldown period. I'm going to lower that to 60 seconds. But unfortunately, because it's already started trying to provision one of my instances, that instance is going to have a 300-second cooldown period associated with that. And we'll see what that looks like later in our video. If I go to my activity history, we've already initiated a spot request. And you can see I have an instance coming up. Now, just so we can tell our instances apart, I'm going to give this the name of scale 1, and we're just going to wait a bit. So now our desired number is at 2, and that's because we've been at a high enough CPU utilization that that's triggered the CloudWatch alarm to spin up another instance. And again, it's going to create a spot instance request. And you can see it's pending coming up right now. And I'm going to give this the name of scale 2. And you can see our first instance, it is pegged out at 100% and it's still going. Now we've triggered the third instance and the CloudWatch alarm has gone off and we're trying to provision another spot instance. If we go over to monitoring for our scale 2 instance, you can see the rapid climb up and it's at 100%. But our first one has finally reached that 10-minute timeout and it's dropped off. So we should expect the overall aggregate CPU utilization for the fleet to go down. And that's exactly what's happened here. Our desired instances are 1, and so it's terminated 2 of the other instances. And you can see our CPU utilization really dropped off. So we still have instance number 3 left. You'll notice that it terminated 1 and 2 before considering terminating 3. There's a way you can configure that in termination behaviors, but in general, it'll terminate the oldest first, but it also tries to balance the terminations across AZs. I can manually go in here and put a minimum of 0 and a desired capacity of 0. And as you might guess, that's going to completely shut down the last remaining instance. And so it's shutting down now. Now we can take a look at the profile. What actually happened during our scaling events? So when we first created our auto scaling group, it immediately launched 1 instance. But you can see there's about a 5-minute or so time period between when it originally launched instance 1 to when it launched instance 2, and subsequently it very quickly launched instance 3. And that's because what I told you about the cooldown time. So that first instance had a cooldown time of 300 seconds. And that just means that AWS is not going to do any other further scaling events until that cooldown time elapses. And the idea is that you want to stabilize the load. You get the new machine in the landscape, make sure it's settled, make sure it's absorbing traffic, and then reevaluate the need to scale. By reducing that down to 60 seconds, you can see the step from 2 to 3 happened more or less within about a minute. Something else to note here is you'll notice my granularity for measurement is at the minute period. And that's something you only get with detailed monitoring enabled with your EC2 instances and your auto scaling group. Now, if I had just basic monitoring, then the granularity would only be 5 minutes. And so we wouldn't be able to see this minute by minute profile. So that's something to remember if you have the need to scale on a minute by minute basis, then you're going to have to use detailed monitoring because it provides that tighter granularity of minute level measurements.